Test, test. All right. Are we ready? All right. All right. Thank you, everyone, for being patient. We had technical difficulties. My laptop decided to throw authentication errors, of course. All right. We're going to get started. Thank you all for coming. Oh, Eco's here. Excellent. What's up, Eco? My name is Evan. My NIM is Vnprc. That's a mouthful. You can just call me Evan. It's what my mom calls me. My open source project is called Hashpool, and we're going to go through it real quick. So what is Hashpool? Hashpool is a new kind of mining pool that emphasizes privacy and community. And really, it's a combination of two ideas. Accountless share tracking, thanks to the magic of eCash, and it is a modular mining pool stack. And if that is confusing, just think of it as mining pools mining upstream to other mining pools. So let's dig into each of these concepts a little more. So what is eHash? eHash is a play on words. It comes from eCash. eHash is a mining share represented by an eCash token. eCash is best thought of as a digital bearer asset. I think of it like it's a banknote with no serial number. So this is a digital token that you can pass around that has super good privacy properties. The benefits of eCash over account databases are pretty big. It's super private, very granular, meaning you can exchange very small amounts of value, and it's very fungible. It is peer-to-peer cash. It really is peer-to-peer electronic cash, like Satoshi said in the white paper. Same thing with a little bit different trade-offs. When you represent mining shares as eCash tokens, this is a pretty cool concept because you can split or join shares, you can trade them around permissionlessly to other people, and you can keep them secret from almost everyone. A really interesting thing happens when you, so normally eCash is used to represent Bitcoin. That's the most common currency. It's a native digital hard money currency. When you trade around mining shares as eCash tokens, kind of a very interesting property falls out. Mining shares actually don't have any hard money backing. It's it's really a promise to get paid out some Bitcoin from the mining pool when a Bitcoin reward lands at the mining pool. So we're trading around promises that mature over time, and the expected value of those mining shares fluctuates until the Bitcoin mining reward arrives at the pool. We have a word for this kind of instrument. This is called a financial derivative. This is an instrument whose value floats and can be traded until it matures. So why would you sell eHash if you mine some up? A couple of good reasons. You can get immediate liquidity, so you don't have to wait for the mining pool to find a mining reward in order for that eHash to mature. You can sell it to someone today, perhaps at a discount, and get your money out early. This is also a way to offload risk. So mining is an inherently risky process. Bitcoin blocks come at random intervals. Nobody can predict when. Your ASIC miners are just guessing all the time. You can offload this risk to a third party by selling your shares for a guaranteed value now. And the other thing that this unlocks is predictable payouts. So this is why miners mine to pools, generally. If you just have an ASIC miner and you're running it and you don't know when the blocks are going to land, you can't predict when your payouts are going to come. But if you pool this risk together and share the rewards, you can now have predictable payouts. We know, thanks to the power of statistics, that with enough hash rate, we're going to find blocks at a fairly regular interval. We can get regular payouts this way. So that's why we sell eHash. Why would you buy eHash? A couple of good reasons also. You can actually dollar cost average into Bitcoin at a discount. So this is the other side of offloading the risk for the miner. If you take on that risk, you actually should be able to acquire Bitcoin at a lower price on average. Privacy. So if you trade eHash, thanks to the properties of eCash, it's super private. It's peer-to-peer electronic money. Nobody in the world knows who is buying and selling eHash except the two parties involved in the transaction. eCash really is magical. And you can arbitrage mining risk. This sounds like some financial stuff, and Bitcoiners don't like to do financial speculations, but I'm actually the most excited about this property down here because it will enable a class of third-party traders to arbitrage the risk of mining rewards. Right now, today, only the largest mining pools can price hash rate. With eHash, we can push this capability down to the bottom of the stack. Anybody in the world can permissionlessly buy and sell mining shares and serve this role of pricing the mining risk. So this is a way, in my mind, to democratize this capability. Take it from the big guys and give it to everyone, like Prometheus bringing fire down from the mountains. I love this part. So what is a proxy pool? It's a pretty simple concept. It's just a mining pool that mines upstream to a larger pool. So in this diagram over here, we've got the small-scale miners on the bottom nodes of the tree. They're mining upstream to a proxy pool, in my mind, perhaps a Bitcoin club runner. And that proxy pool mines, he just passes those shares along upstream to a larger pool that's looking for Bitcoin blocks. So in this diagram, the aggregator pool is the big guy who finds blocks, and he makes a payout to the proxy pool when a block is found. The proxy pool passes those payouts through down to the miners that mine up to them. I think this is a much better design. So right now today, almost all mining pools are aggregator pools, and almost all miners just mine directly to them. The problem with running a small mining pool is you need to find blocks, and this is a very big hurdle to overcome. It takes a lot of hash rate to find blocks. You need like an exahash to find blocks regularly enough to stay in business. So this kind of locks out small community mining pools. But if we just have pools mining to pools, we can pool our risk in a tiered layer. The benefits are community-oriented mining pools. My vision is to have Bitcoin club runners who are selling bitaxes to their club members. They can run their own mining pool permissionlessly and serve as a trusted pool runner. You can't really shake hands with your mining pool runner today. Anybody? What's the CEO of Ant Pools? Anybody shook his hand before? No, you can't get to that guy. No, why would I trust him? I can't shake his hand. And it enables self-sovereign mining pools. So anyone can spin up a mining pool, point their pool upstream to an aggregator, and you might think, wait a minute, that's not self-sovereign. You still need to trust someone. You still need to mine to someone. But you can have your local community who trusts you, and then if your upstream pool rugs you, you just point all of that hash rate to another pool. In this way, we have optionality. We can choose our upstream aggregator pool and really be self-sovereign, community-oriented mining pools. So how did it start? I've had this idea kicking around my head for a long time. I was working in the Bitcoin industry in July of 2024 until I got laid off. And then I was like, YOLO, let's do it. Let's go build this thing. So in October of 2024, I traveled to Berlin for the BTC++ eCash edition. Shout out Nifty. Thanks for inviting me. I presented the concept. I didn't have any code, just the ideas that I had been thinking about for a long time. In November, after I came home from the conference, I created the repository on GitHub. My plan was to iterate fast, learn as I go, work on it every single day, no exceptions. My tech stack is all Rust. I'm using Nix to orchestrate things. I'm building on the Stratum v2 reference implementation. This is sort of the next gen mining protocol. This is the protocol that miners use to talk to their pools. And I incorporate CDK, which is the Cashew dev kit. This is an eCash library, and I'll talk about that a little more later. These were all new skills. I had just finished the Rust textbook before I got that job. That job was all JavaScript, no Rust. So I wasn't really thriving there anyways. So when they laid me off, I was like, let's go back to Rust. And YOLO, like, what are we doing with our lives? Are we working for companies forever? Are we going to go build something that matters? And the other kind of ace up my sleeve was I was getting more and more into AI and LLMs. And I knew that this superpower was coming, and I wanted to skill up in that area. And I'll talk about that a little bit at the end. So how's it going? It's going really well. I am deployed on testnet 4. Thank you. I have proxy and aggregator pools deployed you can go to pool.hashpool.dev. Check that out. I'm working on the hash rate graph right now. It's a little rocky, but it's getting there. Proxy.hashpool.dev. You can actually get the mining details and point your bitaxe to it right now if you want. I've got a couple bitaxes pointed to it myself. I have published the draft spec PR for the eHash protocol. The Cashew developers are funny guys, nuts. Their protocol repo is called the Nuts repo. It's a backronym, it stands for Notes, Usage, and Terminology. This is a play on words because the Lightning repo is called Bolts. So you've got eCash and Lightning, nuts and bolts. Ha ha ha. My protocol is called NutXX. You don't get a number until it's deployed to 2 implementations. So I'm pretty far off from getting a number assigned, but it's called the mining share payment method protocol. Also, when I started the project, I just forked Stratum reference implementation at whatever the top level commit was on that day, which is actually, it wasn't quite 1.2.0, it was a couple commits before. And I just iterated on that. I needed a mining platform to build on to sort of figure out the eCash pieces. So I built on that for about a year, and then when I felt a little more comfortable, when the protocol was more stable, I did a massive lift and shift using AI, and I reapplied the whole thing on top of the 1.5.0 repo. I was able to knock that out in a week, thanks to the power of vibe coding. It's amazing what you can get done these days. Super pumped about that. So what are the next steps? I'm running on an old version of Bitcoin Core right now. There's a core developer named Shores Provoost. Shout out, Shores, if you watch this prezo. Respect. Shores is working on the template provider interface, which is now active in Bitcoin Core v30. They did a lot of work to split up Bitcoin Core into multi-processes and open up this IPC interface. I'm very excited to get on that and off the old branch. I want to migrate from the pool role to the translator role. This will unlock mainnet. Brains Pool is a mining pool. They co-invented or perhaps invented the Stratum v2 protocol. They've had a Stratum v2 mainnet pool running for a while. I'm very excited to get off of testnet and onto mainnet, where you can mine up real sats with your bitaxe to your Cashew wallet. And then the big looming hurdle. Right now you can mine eHash, but you can't convert it into sats yet. So that's a big step. I'm very excited for that. The first thing I'll do, I think, is swap eHash tokens for eCash tokens. So this is also an eCash token that is backed by Bitcoin. A lot of Bitcoiners really don't like eCash because it's a custodial system. I hear you. The next thing to do after that would be to swap eHash for Lightning payouts. It's not a big lift. I think it will be fairly straightforward to get that going. Because once you have eCash tokens, the way the Cashew protocol works is you can just peg out those eCash tokens for Lightning and take custody of your sats. I know we're all big fans of self-custody. I am as well, and I'm excited to get there. So let's take a look at the process architecture. It's pretty simple, as you can see. Here we've got this is the proxy pool. So this is the small community pool. Over here on the right side, we've got the aggregator pool, which is the big guy that finds the blocks. We've got a Bitcoin D node that talks to the job declarator client. This guy helps you build block templates and decide what transactions go into your blocks. Well, I'm not actually using this right now, but I plan to in the future. The translator proxy talks Stratum v1 downstream to my bitaxe miners and Stratum v2 upstream to the aggregator pool. These are the JDC, the translator proxy, the pool role, and the job declarator server are all Stratum reference implementation. They're called roles, or they're processes. They run as processes in my deployment right now. I've also vibed up my own new application layer roles to collect stats from the translator proxy and display them on a website. Same thing on the pool side, collect stats from the role and display them on the website. I've also added a mint role. This does the eCash stuff. So how does that work? Well, a couple notes. I'm hoping to simplify this. I did have a Lightning node on here as well, but CDK has recently rolled out Bolt 12 payments using the LDK library, the Lightning Dev Kit library. So I deleted that because I can now roll the Lightning node into the mint role. So compressing this complex graph. Also, the SRI project is planning to add translator functionality to the job declarator client. So you can build your own block templates and talk downstream to SV1 mining devices in the same process. I'm pretty excited about that. We can collapse these two together. All right, so how does it work? What happens when you send a share upstream? So the proxy, this guy right here, I've bundled up a CDK wallet into the proxy. So what happens is your BitX miner sends a share upstream to the proxy. In the config settings, it has a public key. It's going to bundle that public key with the share, send it across the internet to the mining pool. The mining pool is going to take that information and create a quote at the mint. So this is like a request to create some eCash. And then the proxy, so actually not depicted here, the mint actually sends the quote ID back to the pool. The quote ID goes back through the internet to the proxy. The proxy has a polling loop process that says, okay, I got some quote IDs. Let's ask the mint if they're paid and can be redeemed. And whenever it finds some, bam, it receives the eHash directly into its wallet. Pretty simple. This is a nice design because it protects the privacy of the miners, but it's not quite the usability, it's not quite the UX I'm looking for, because this is a hosted service. So this person right here has to run an always online mining proxy on their Umbrella or home server or Linux box or whatever. So I think we can do better. I got this 90% built, but not quite done yet. This is the usability I'm really looking for. So here we have a user who does not need to run their own hosted service. They can actually just perhaps buy a BitX from their Bitcoin club runner who does run a service. And then when they configure it, they're going to generate a Cashew static payment address. And they're going to register that at the proxy mining pool. Now, when they send a share to the pool's going to know to associate that share with that static mining address. I still have to figure out how that association happens. I don't think it's going to be a big hurdle. And again, the rest of it happens kind of the same way. The share and the pub key go to the pool, creates a quote. The proxy polls for quotes. When it gets the eHash tokens, they are locked to a private key that is encoded, or a public key that is encoded in that static address that only the miner knows. So we have locked eCache now, locked eHash at the proxy, and we can automatically forward that to a Nostr relay encrypted to the public key encoded in the static address. And now we just need one more polling loop. For the miner's Cashew wallet, goes to Nostr. Whenever they pull up their wallet, it connects to the Nostr relay, sweeps those eHash quotes, and bam, the user has some eHash in their wallet. This is the usability I'm driving at. I want people to be able to buy a BitX, configure it, and watch the sats land in their wallet in real time. All right, so the secret ingredient of all this magic is Cashew. Cashew really is the Lego bricks of money. That's the Cashew logo over there. I love that guy with his sunglasses. Deal with it. In this flow that I've just described to you, there are three primary protocols that I'm leveraging. NUT20, signature on mint quote. This prevents a man-in-the-middle attack when you send your quote from the proxy to the pool and to the mint. Nobody in that link, in that chain, can steal it. I should note that the mint is a trusted party. In all eCash systems, you have to trust the mint. The magic of eCash is that everything is super private. The mint does not even know who you are. So their choice is they can rug you, but they can't rug you specifically. They can rug everyone or they can rug no one. And that's kind of so in this way we can develop a reputation market, and the mints can protect their reputation by doing a good job for all of their users. I also use the NUT11 pay to pub key spending condition. This is actually included in the NUT18 static payment address. So NUT18 builds on top of NUT11. This prevents a man-in-the-middle between the wallet and the proxy. So the proxy cannot steal your eHash until the proxy cannot steal your eHash hard stop. They encode it, they encrypt it, they send it as a Nostr DM, and you claim it off the Nostr relay. That's just this flow that I showed you. Like, that's this. There's a lot more that I'm looking forward to doing. Nut 13 deterministic secrets. This allows you to create a 12-word seed phrase and save it somewhere. This way, if you drop your phone in the toilet or clear your browser cache, if you're using cashew.me, you can restore all your eCache from the server just by putting in your 12 words. Super important functionality. Nut 22 blind authentication. I think the perhaps the most common use profile for eHash mining in the future will be an authenticated pool. But with the magic of eCache, again, we can do this in a privacy-preserving way. So the pool runner can have a whitelist of people who are allowed to mine to that pool. Perhaps the government's probably going to want to get involved and control this a little bit. But the pool runner can protect themselves and protect the privacy of the people on that list, because now that whitelist is an anonymity set, and anytime someone authenticates, the pool only knows that they are on that list. They do not know which person on that list is sending these particular shares. Nut 24, HTTP 402 payment required. This one solves spam. Fees solve spam. This is a way to add eCache fees to any API. And Nut 25, payment method bolt 12. This is a Lightning super private Lightning static payment address. This will be key to allow people to take those sats into self-custody. I plan to build all of this. Let's talk a little bit about eHash units. So up here we have a representation of a mining share. What a mining share really is a Bitcoin block header that's run through the SHA-256 hash algorithm. SHA-256 outputs a 256-bit binary number. There's 32 squares up there, but use your imagination. We're going to call it 256 bits. I have the limitations of a projector screen. So first, some terminology. A mining epoch. This is, I'm going to call this the time between mining rewards. So if you run a proxy pool, the aggregator pool finds a block. You get a payout, probably over Lightning. This starts a new mining epoch. You collect shares. You send them upstream to the aggregator pool. The pool finds a new block. You get a new payout. That closes out that mining epoch. So all of those shares that were issued in that time are a distinct eHash asset, because the Bitcoin value of those eHash tokens is determined by the mining reward divided by the total difficulty of shares issued, if that makes sense. So each mining epoch, all of the eHash has an equivalent value to each other within that epoch, but it's going to be different in between epochs because the mining reward is different, because you don't know which transactions and which fees are going to be included in that block that gets found. So this is kind of a problem if we want eHash to be fungible. We want people to be able to trade these things. We want to enable this market of eHash traders. So luckily, hash rate shares have an absolute difficulty value. If you look at this 256-bit binary number, what we're really looking at, we're just counting up the zeros at the beginning. That's how Bitcoin mining works. If you find enough zeros at the beginning of your block header hash, you can win a block. A mining pool just sets a lower difficulty threshold and uses that to track how much work each miner is doing. So this is our yardstick that we can use to compare all of these eHash tokens. But not quite so fast. That's a 256-bit number. Modern CPUs are optimized for 64-bit numbers. In the CDK library, the eCache amount field is a U64, an unsigned 64-bit number. So what we really want to do is represent the useful range of mining share values with a 64-bit number. Fortunately, they fit very well within a 64-bit number. So the solution I've stumbled on, this is the left curve solution. There's probably other ways you could design a system like this, but I look for the dumbest possible thing that could work. So what I did was I just lopped off 3/4 of the addressable share range. I really like this solution because it's future-proof. If you've seen the hash rate graph, it's going parabolic, and it's not slowing down. We get more and more hash rate every day, and it increases. It's like being deployed at a faster rate. So as global hash rate increases, we'll be able to use a larger offset. The offset is how many 0 bits we just sort of lop off to the beginning here. This also enables pool specialization. So if you want to run a proxy pool that caters to very small miners, have you guys, maybe you've heard of the Nerd Miner? It's a little USB dongle that mines Bitcoin on a ESP32, super, super low power device. You can just slide this window all the way to the left and cater to nerd miners. Probably not very profitable, but you could do it. High hash rate pools, likewise, they can just slide this window to the right, and their individual ehash tokens will be worth comparatively more. I've found that 32 bits is a nice offset to start with. On my dev environment, I have a CPU miner. Most of my testing is done with a BitAxe. Shout out to Scott. So 32, lopping off the 32 leading 0 bits here is small enough for a CPU miner to find shares regularly. And if you just map it out, 64 plus 32 is 96 bits of difficulty. And I looked on the blockchain, and the best share ever found on the Bitcoin blockchain had 94 bits of difficulty. So this is actually 4 times harder to find than the best Bitcoin block that has ever been found. That's not going to stay the same. If you look at the hash rate graph, we're going to have to go up, but it's kind of nice how this fits very nicely today. All right, so what are we looking forward to building here? I'm really this is a new possibility that was opened up to me. I got on a call with Callie and tried to plan out how payouts would work. And we brought up the question of, can the mint be a third party, like totally unassociated from the mining pool? And we think it's possible. I'm pretty excited. This is a enhancement in privacy and sovereignty. And I think perhaps legal clarity, because it's a separation of concerns. The mining pool can now focus on only mining, and it offloads the eCash piece to another party that runs the mint. Could be anyone. Legal clarity, I put a question mark and a shrug emoji here because if you've been following the news lately, our farcical judicial system is now locking up open source developers for running non-custodial money transmitting services, whatever the fuck that means. I don't know. Like, hopefully the situation improves, but I don't know. Not making any promises here. This is going to require some new cashew protocols. We're going to have authenticated quote creation and authenticated asset creation because the pool itself needs to be the only party that can create these new eHash assets every time the mining epoch rolls over, and creates the quotes every time a share is received. No problem. That'll just be some more nut specs on the nut repo. I'm also looking forward to block template creation. Right now, I kind of just sidestepped this whole thing. Currently in the dev environment, the aggregator pool is the only entity creating block templates, and the translator proxy just mines on them. I think we can push that down in 2 stages. We can have the proxy pool building its own block templates, and then eventually we can actually have individual miners mining their own block templates that get passed up the chain. This is all possible with Stratum v2 protocol, similar to the way Datum works. I'm building on Stratum v2, but it's the same idea. This is important for Bitcoin, for Bitcoin's decentralization properties, because we want as many parties as possible constructing block templates and deciding what goes in those blocks. This is like a key capability and a key principle of the Bitcoin network. This is going to take some work, though. Someone needs to build out tools to validate the block template. I think this exists already in the SRI project, but we also need to value those block templates. Since block templates contain different transactions with different fee rates, they're going to be valued differently. Also, you could mine perhaps an empty block template. That's not the same value. Those shares getting sent up to the pool are worth less, because if you win that block, everybody who's mining on that pool has to share the same fees that you mine in that block template. So if someone is mining a full block template, those shares are worth more because they include more of potential payout. If someone is mining an empty block template, those shares are valued less. And there's different ways to do this. We need to figure out what works best for Hashpool. And perhaps something, this is really sci-fi, really out there. I want to build a permissionless transaction acceleration network. So if you've gone to mempool.space, they have a transaction accelerator. What this is they're just tapping into a bunch of closed source private APIs run by other mining pools. I think I know Marathon has Slipstream. Some other pools have some APIs, maybe F2 pool. Don't quote me on that. These are closed source private APIs. If we want Bitcoin to truly decentralize, we want to decentralize the mining pool world, we need a permissionless solution. The trick here is you need a way to attach a fee to a transaction that anyone can claim when they mine that transaction and at no other time. Only the party mining the transaction should be able to claim these fees. I think this is possible with a combination of Nostr for a permissionless relay network, eCash, and DLCs. eCash supports DLCs, and on-chain Bitcoin can also support DLCs. So the key principle here is you need a distributed network of Bitcoin nodes to act as oracles for all of the transactions or all of the Coinbase outputs that are put in each new block. I think this is possible. I'm excited to experiment with this. Another big, hugely impactful idea is I think we can build verifiable mining using the power of eCash as well. And this comes in two big pieces. For anybody who's studied finance knows there's assets and liabilities. As every business, a mining pool, the liabilities are the shares, the promises to pay out to the miners who sent shares to you. We can publish all of these, since these are represented as eCash assets. There's a proof of liabilities. Really, it's not a protocol yet. It's kind of a sketch right now. But the idea is every time you interact with an eCash mint, you create something, you create these two artifacts, a burn proof and a mint proof. Every time you create an eCash token, some random data goes into a database at that mint. That's the mint proof. And when I send an eCash token to someone else, what happens is they destroy that token and they get a new one using some new random data that they generated. That's called a burn proof. All of those go into the database at the mint. And when the mining epoch closes out, we can take all of this data, add it into a Merkle sum tree, make sure that the total amounts add up to these two, at the roots of these two Merkle sum trees, and ensure that the mint did not inflate the asset. They didn't print any cash that wasn't backed by some asset. In combination with this, the pool can issue a proof of assets. Since we're dealing with Bitcoin mining, everything is verifiable. We know all of the Bitcoin blocks and the blockchain. We can keep track of all of the block templates that miners submit, and we can keep track of all of the shares that they submit. And verify by taking that block template, take the block header, hash the block header, make sure it all adds up. We can publish this also in a Merkle sum tree, and we should have now 3 Merkle sum trees that equate at the top, at the root level of the tree. In this way, we can prove without doxing anyone's identity, without violating anyone's privacy, we can prove that the mining pool operated 100% fairly and accurately, I think. But I have to go out and build it to be sure. Another exciting prospect that I'm interested in exploring is Spillman channels. So these are a different, older kind of payment channel. The Lightning Network uses a bi-directional payment channel called a Poondrija channel. Spillman was a little earlier. Didn't really catch on, but I think maybe the time is right to explore further because it really matches the mining use case better than bi-directional Poondrija channels. For mining, if you think about it, the pool only ever emits Bitcoin. It only ever creates Bitcoin and gives it out to people. There's no use case for people to send Bitcoin to the pool, so we don't really need bi-directionality here. Also, the mining pool is expected to have regular payouts. If you're not finding regular blocks, your miners are going to go away, your pool's going to go out of business. So we need to have regular emission of new Bitcoin. This is interesting to me because it's kind of sidesteps some problems in the Lightning Protocol. The Lightning Protocol developers used miners to escrow small HTLC amounts. So the way this works is if you send, for example, 10 sats, any amount under the dust limit, what happens is you've got a Lightning channel. You actually create an output on that Lightning channel while the payment is being processed. And for very small amounts, we can't claim those on chain. The idea in Lightning is you can close your channel out at any time if anything goes wrong, take your money on chain and go home. But these amounts are smaller than the dust output, so we can't reasonably create these outputs on the Bitcoin chain. So what we do instead is we just kind of shunt those payments off into miner fees. The idea is this is a small amount, you're not going to miss it. It's going to be like a very uncommon use case. But it really kind of shoots us in the foot when we want to think about using mining pools to do payouts over Lightning, because it opens an attack vector. The attack vector is this. I'm a mining pool. I have a Lightning node. I open a channel with someone else. I can jam the channel with small HTLC outputs. I think you can fit like 300 or so of these into a channel. And then I just take my node offline. So I've got 300 outputs with 300 sats each. Take my node offline, mine the force closed transaction myself into a block. And because those fees go to the miners, I get to claim those fees. So sort of the protocol was designed without kind of taking miners into consideration. And I think this is a weakness, and it's gonna, if we continue down the path of decentralizing mining and doing Lightning payouts, I think this is probably gonna blow up in our faces eventually. Uh-oh. Can you touch my computer? Oh no. All right. BRB. All right, we're back. And one thing that kind of pops into mind is the ARC protocol. The ARC protocol is kind of very similar to the mining use case, a lot more similar than the Lightning protocol. So I'm excited to explore the ARC protocol. It has a regular, sort of pegs in transactions into the blockchain regularly, which matches the expected regular payouts of a mining pool. And the ARC protocol uses something called an ARC service provider or a liquidity provider. This is someone who injects Bitcoin into the system to pay for all these. They're called VTXOs. These are off-chain UTXOs, or off-chain transactions. So the mining pool itself is creating new Bitcoin at a regular interval. It can serve as a liquidity provider to the ARC protocol. So I'm very excited to dig into that protocol and see how we can leverage it here. I wanted to make a couple notes on covenants and self-custody. I was exploring at a hackathon at a BTC++. I was looking into some covenants use cases for mining pool payouts. And I was kind of disturbed by what I found. So here we see what a common custodial payout looks like. All mining pools today, with the exception of Ocean, are custodial mining pools. The Coinbase is the first transaction. It's where all the new Bitcoin gets put when you mine a block. And in a custodial pool, it's very simple. You take that Coinbase, you roll it into your custodial wallet, your single mining pool wallet. It's a very small transaction. And you can maximize the rest of the block space for transactions that pay fees. So you can maximize your profitability this way. For non-custodial Coinbase payouts, you need to put all of those outputs in the Coinbase transaction, which causes the Coinbase to grow in size. This actually cannibalizes the block space that you can use for transaction fees. So this creates a perverse incentive on the Bitcoin network for custodial mining pools to outperform non-custodial mining pools. It really grinds my gears that nobody talks about this. CTV, which is a new opcode proposed, it's a kind of a covenant, which is a way to control what a transaction looks like. So you can create a UTXO on chain, and you can add this script in there that locks down exactly what the next transaction looks like. That can be that this Bitcoin flows into. I love CTV. It's like the left curve solution. You just specify exactly what the next transaction looks like, and it stops after that. It's not a recursive covenant, so it doesn't like trap your Bitcoin in some kind of feedback loop or any of this crazy stuff. I actually built this on a little test environment, and it worked perfectly. We can completely destroy this problem. We can the way it works is you take the Coinbase payout, you point the entire thing into a CTV transaction, which is a very tiny on-chain footprint in the Coinbase, and then you've got this very large fan-out transaction that you need to get mined in the future. The Coinbase cannot be spent for 100 blocks anyway. That's a Bitcoin consensus rule. It's been in there from the beginning. But if you have a CTV payout tree in your Coinbase, we can have on-chain guarantees for every miner who contributed to that block. You get a Bitcoin consensus guarantee that your payout will be included at some point in the future. I hear a lot of people, I'm very involved in the covenants debate. I see all the time people worrying about the risks of activating covenants. Nobody talks about the risk of inaction. So inaction is a choice. I don't think it's a good choice. I think we need CTV or something like it for non-custodial mining to really take hold, for trustless, decentralized mining to take hold. So what are we waiting for? Let's activate this thing already. It makes Bitcoin stronger. Some comments on AI. Cypherpunks vibe code. I launched this project knowing that I was going to lean heavily on AI, and I've done so. And it's frankly incredible what you can get done these days. If you guys are sitting on the sidelines, like waiting to see how this pans out, get up off your feet, get up on your feet and start vibe coding today, because it is a whole new skill set. We are in the middle of a skill reset in software development. You got to get up on the new stuff. We need freedom technology. We are in a race against time. CBDCs are coming. We need all of our freedom tech builders using the best tools available. Steve Jobs said that the computer is the bicycle of the mind. I firmly believe that LLMs are the combustion engine of the mind. So let's do this. Start vibing today. All right, some final thoughts. Imagine if you could run a private anonymous mining pool as easily as you could run a Bitcoin node. That's what I'm driving towards. Imagine if you could buy a BitAxe, install a Cashew wallet, and start receiving sats to your Cashew wallet right away with minimal configuration. Imagine if you could buy sats privately and permissionlessly in your Nostr client. Imagine if you could get paid to take hot showers. I'm super excited about the hash rate heating movement. We're going to put Bitcoin ASICs in every home. And I think the holy grail is putting a Bitcoin ASIC in a water heater. We've all got water heaters. We probably all like hot showers. Maybe there's some cold shower folks out there. You can put ASICs in your HVAC as well. I think hash rate heating is how we truly decentralize hash rate at the physical layer and on the ground. Imagine if we had private, permissionless Wi-Fi mesh nets spread across the land. There's a project called Tollgate. Love what they're doing. They're building a Wi-Fi router that instead of having a password, it just has an eCache API. So you can permissionlessly and privately buy Wi-Fi access, pay as you go. They're super, super excited about eHash because they want to put a Bitcoin ASIC in every router. This solves the bootstrapping problem. Your router is connected to the wall outlet. You plug it in at all times, so it's got power. What it lacks is when you buy a new one and set it up and want to connect it to the mesh net, it doesn't have any sats in its wallet. But eHash allows us to convert electricity into sats passively. So you can buy these Tollgate Wi-Fi routers, plug them in. They'll just mine up some sats. They'll just ping the network around them, find out who's around, and permissionlessly open Wi-Fi channels and start routing packets across the mesh net. I'm ridiculously excited about this, bullish on Tollgate. Imagine if we had a free global market for hash rate. So if you guys, anybody here a fan of BitChat? Love BitChat. I think they have solved the geography problem for us. They have a concept called a geohash. This maps the entire world in a very short string identifier. And what happens when you go to BitChat is you can connect with someone, and then when you walk away, you can no longer connect peer-to-peer with them on Bluetooth. What happens is your packets flow up to the Nostr network. You just find the nearest Nostr relay using your geohash tag. I want to roll this into Hashpool as well, and I think once we do this, once there's Hashpools across the land, locally identified with their geohash, we can have private global markets for hash rate everywhere. You just find the nearest hash pool, you mine up some eHash, you can buy, sell, and trade it permissionlessly peer-to-peer. This is a single global market for hash rate, powered by Nostr. Love it. Imagine if we had a free global market for energy. This one blew my mind. I went to the Type 1 Summit at Presidio Bitcoin last week. Love it there. They got a bunch of energy VCs and AI nerds together to talk about, to kind of try to trick them into buying into Bitcoin. It was hosted by Bitcoiners. I was the hash rate heating guy who got up on stage and tried to heat punk pill them all. And they kept talking about a global market for energy. And it sort of flipped a switch in my brain because I realized if we have a free global market for hash rate, a free global market for energy is just the inverse of that. You can announce that you're mining Bitcoin using your Hashpool instance, and you just add an identifier that says anyone can buy my power. You just have to pay more than the Bitcoin rate. So this is called demand response. It works right now today at utility provider sites. So an electric utility will set up a Bitcoin mining farm nearby, and they'll actually have a contract where they pay the Bitcoin miners to turn off their Bitcoin ASICs. Maybe there's a winter storm coming through Texas. Maybe there's a heat wave. But if the electricity price goes higher than the Bitcoin mining base floor price, you can actually just pay the miners to turn off and use that energy for other more valuable purposes. We can build this in a permissionless fashion as well. My name again is Vnprc. Find me on Nostr. I'm not on Twitter. Twitter sucks. I got canceled off of Twitter. Find me on Nostr. That is a link to the primal Nostr client. You should all install it today because Nostr is awesome. My website is hashpool.dev. Check it out. I've got a nice explainer article there that covers eCash and other topics at a high level. GitHub, Vnprc. Also check out trianglebitdevs.org. We have monthly meetings. We dig deep into the Bitcoin protocol technical stack. I would love to see you there and have you contribute your voices. That's all I got today. Do we have any questions? Thank you.
A couple questions. First, yeah, love eHash, great presentation. Something you mentioned is that eHash is like a unique asset tied to the specific block, right? So my understanding is that you would price that as just like the number of eHash shares produced, or the block reward divided by the number of eHash shares produced. But you also mentioned a concept of making these fungible across pools due to difficulty. So how do you square that? Like I would assume that the luckier hash would be more valuable than the less lucky hash.
Yeah, so for a speculative market, you can compare. So all eHash has one has a measure on the same yardstick, and it's this. It's the absolute difficulty of the share that mined that eHash. Does that make sense?
Well, so like that makes sense in a vacuum, but like also I thought that okay, if you're these are all different assets tied to the block that was rewarded for that share, then the price of the hash after the block is mined should equal just the proportional, like the number of shares that went into the block. No.
Yeah, it's not number of shares. You are measuring the difficulty value of each share and sum that up to get the total difficulty that contributed to that mining epoch.
So what if that number doesn't actually equal the block reward?
Then your shares. So we're talking about apples and oranges. These are two different measures. The measure of the difficulty contributed to the mining epoch is the top of your equation. Apologies, this is a side-to-side equation. I didn't write it out like a math equation. But, that's the denominator. Total share difficulty is the denominator, and the mining reward, which is how many sats you earned when the pool found the block, is the numerator. So you just take that, divide it by that. You get a value for each share.
So mining reward is per share, or is it per block?
Per block. If you're mining blocks. If you're a proxy pool, then you get a share of each block that the upstream pool mines. Does that make sense? That's why I call it a mining reward instead of a block, because there's different models for it.
Okay. I'm getting lost, but we should talk after. How could it be fungible if you have one pool that mines one block with 10 people mining and they each produce one share, and another pool that mines with it's the same difficulty, but they get lucky and they only take 5 shares. Pool number 2 should be those shares should be worth twice as much as pool number 1, even though all of like the bits are the same.
Correct.
So
that's why you need to trade eHash before the block reward is found. This is what makes it a derivative, because the value floats and it might wind up being higher or lower than expected.
Okay, so you fix the exchange, so it becomes non-fungible once the block is mined.
Yes. Once the block reward is found, the eHash token's value in Bitcoin is locked. And what I'm planning to do is turn off eHash trading. Now we have a stable coin. Now all of the eHash tokens for that mining epoch are just Bitcoin stable coins. So we're not in the business with stable coins. You should just exchange those for eCash backed by sats.
Gotcha.
Does that make sense?
Yeah. You just have an exchange, like a rate per like unit eHash to sats.
Right, and that's why there's a market
after
for traders, because they can arbitrage this risk. They can buy and sell the risk, and sometimes they get lucky, and sometimes they get unlucky, and that eHash value.
That's really cool. Okay, thank you. That completely answers my first question. My second question.
Excellent.
Big fan of privacy of eCash. I'm wondering how does the you talked about like async payouts using Nostr DMs. Does that not negate a lot of the privacy properties that the eHash provides?
They use NIP17 Nostr DMs, I believe, which so basically, yeah, the way you fix that is you don't mine to your public Nostr account. You create an ephemeral identity, which is just a new public-private key pair, and you receive your eCash at that key pair, and nobody needs to know who that identity is tied to.
But when you still need the pool operator to be able to correlate each eHash payment to a single person. Like even though you don't have the face of that person, like you still have like you lose like the anonymity set of all of the eHash. Actually, you still know the users.
Yeah, I have been thinking about that as well. I think you can rotate the key set. I think you can just rotate that private key regularly and claim some of that anonymity back. But you're right.
Yeah, I think in order to like really preserve like the true anonymity set of the eHash mint, you would have to do new keys for every payout. But then even then,
you could even do new keys for every share. I don't know.
That's what I mean. Yeah,
that might be a little heavyweight. We'll see how it pans out in practice.
Anyway, thank you.
Yeah, great question though.
Curious about so in comparing Spillman channels versus Poondraja, like two-way channels, is my thinking in lieu of something like CTV is that you could basically make a simpler version of ARC that just aggregated the VTXOs, because the connector model inside of ARC basically does the purpose that CTV has of making sure that there's one UTXO that's quote unquote stamped with the ownership of 100 people, 1,000 people inside of it, and that you could actually use ARC specifically for that, and then just remove the whole idea of like, oh, I'm going to exchange payments, or there's going to be a bunch of pending payments between a bunch of people, like I'm going to pay somebody else in the mining pool, because you don't need that. You can basically have a Spillman designed ARC that just pushes and aggregates in the UTXO to solve the incentive structure of the Coinbase. Yeah,
I think that's a great idea. Maybe we can simplify it. To tell the truth, I haven't dug into ARC. I'm working on a lot of other next level shit. I haven't gotten that deep into ARC yet, but I think you might be right. One of the tricky things with Spillman channels is that they do not interoperate with Lightning channels. So the Spillman design has a timeout, and the way it works is that I think the recipient of the channel can force close the channel ahead of time, before the timeout, and only the sender can only close the channel after the timeout. I might be mistaken on that, but if we can integrate and unify liquidity between Poondraja and Spillman channels, which is a big thing, we're going to have to add HTLCs probably. What this enables, I think this might like superpower Spillman channels, because now it gives the sender of the Spillman channel sort of effectively a means to unilaterally close. If you can just push the entire liquidity balance of the channel into a Lightning channel, take self-custody that way, now the receiver of the Spillman channel, like all of the balances on one side, there's no reason for them to keep the channel open. They might as well close it ahead of time, because there's nothing left to keep it open for. Does that make sense? So I think if we can unify the balance between Poondraja and Spillman channels, it kind of supercharges Spillman channels. But it's a big lift on the Lightning Protocol side.
Great presentation.
Thank you.
That's all. I guess I have a more generic question. and it's about hash rate futures markets, just generally speaking. First, curious in your thoughts on those. I don't know if those are really much of a thing these days. And then second, it sounds like this is sort of like a hash rate future, but a very short-term one. Am I reading that correct? Like you couldn't use this to do hedging a year out, for example.
I believe you're correct. Yes, this would be a short-term hash rate future that only applies until the block reward is found. What do I think of them generally? I think I have seen a number of proposals. People are trying to solve this problem. I've seen DLCs proposed. I think there is probably demand for this. People are trying to do it at a high level in a centralized fashion. And I was just trying to find out when I stumbled on this idea, I was trying to find applications for eCash. I'm a huge eCash nerd. I just love the privacy properties. It tickles my brain in just the right way, in all the right places. And I was thinking, what could we use eCash for other than Bitcoin? And really, the technology shines for things that have inherent digital value. The first place I went was auth tokens. Have inherent digital value. We actually have auth token support in Cashew, which is great. Down here, the NUT22 blind authentication. That wasn't that exciting to me, but I was getting deeper and deeper into mining, and I thought, oh, mining shares have inherent digital value. What kind of a system could we build that represent mining shares as eCash tokens? And the more I pulled on that thread, the more I became enamored with this idea. So I'm not coming at it from a top-down problem. I was trying to find applications for eCash, and mining is kind of broken. Hopefully no one here disagrees with that assertion. And I think maybe we can fix some of those big problems with this. It really is an intersection of different protocol areas. Mining and eCash and Bitcoin protocol developers and Lightning protocol developers, they kind of tend to stay isolated in their lane. And I just sort of, I'm a super nerd. I love learning about all this stuff, going deep and broad. And I found I've found that there's all these cool connections when you understand the protocol stacks of different areas. You can find cool connections that other people miss. So I just want to push this technology as far as we can, see what we can do for privacy, self-sovereignty, improve Bitcoin for everyone. Does that answer your question?
Thank you.
Thanks. Anybody else? Question in the back.
So in the context of fundraising, for example, recently I helped Bitcoin Veterans Initiative, Operation Bitcoin, run a telehash. Thanks 256 Foundation for coining that, and awesome job on hitting the block.
Love those guys.
I'm my wheels are really turning right now, so I apologize if I'm not making complete sense here, but I'm kind of seeing this as a way to, one issue that we're having is like incentivizing big companies or individuals to donate hash rate, because there's no real good way to write this off, like write it off on your taxes. So that's something that companies are really looking forward to, and as an incentive for their donation. I'm kind of seeing this as a potential way for like these eHash tokens could then be used as something of value, or that you could assign a value to in order to write that off on your taxes. I don't know, am I kind of understanding how this is working? Like, is that a potential mechanism, do you think, to do that with, or?
I'm not a tax lawyer. I'm like as far away as possible from that stuff. I think you're gonna, I'm not sure how it works. You should definitely keep track of your costs, which in mining terms is your electricity cost. If you sell your eHash before it matures, you can recoup those costs, and compare like what you earned versus what you spent. If you give those shares away, I mean, so this is where the market comes in. This is where we need a class of traders who can price this asset appropriately. And I'm not exactly sure how that works. Honestly, I don't think I need to solve that problem. I can just build eHash and put it in people's hands, and the peer-to-peer markets, I believe, will just emerge in an emergent fashion. But what we need is a clearinghouse. I anticipate probably a Nostr relay where orders can be placed and filled, and you just need to pay attention to that market and value these shares according to what the clearing price is on those decentralized markets. Again, I don't know about tax implications, not my area of expertise, but that's how I would approach the problem of pricing hash rate before the mining reward comes.
On that emergent market for speculators to trade the hash, they're basically betting on like, oh, this will find a block. Or I guess they're betting on the upstream aggregator pool to get some share.
Yeah, I think really what you're betting on is how soon will the next block reward arrive.
Okay, and so then the window of time that they're speculating against is basically the top of funnel pools, whatever it's called, density function, like observation window that they use to pay out shares.
I'm not familiar with that term. Can you say it again?
So like when I give shares to Ocean, I don't know exactly how it works, but I think I get paid, there's like an observation period of like what your hash rate was. Whatever that observation period is kind of like your forward speculative derivative market for the hash. So, because someone was asking, like, can I hedge a year's worth of hash rate for a big miner with this concept? I think you're only hedging whatever that interim period is that you're not getting paid if you just mine with the pool direct. So I wonder if maybe there'd be a situation where a miner would enter a longer term agreement with a pool, which would then give their e-hash a longer duration, which would give the speculators a longer term financial product to do their speculating on.
Sure. Sounds great to me.
'Cause
If you want a longer term, you can just mine blocks yourself. Bitcoin blocks are going to be found less commonly than if you're plugged into an aggregator pool. So that's one thing you can do, but that's not a very good, that's just like a switch binary. It's not a knob you can turn. I think it wouldn't be that, it shouldn't be that difficult to just, you're going to have to go outside of the protocol and make an agreement with someone to price a long-term hash rate. But you can look at the hash rate that you're producing. You can look back historically at how much that hash earned in mining rewards up until now. There's a lot of future uncertainty, though. Like, if you've seen the hash rate graphs, it goes straight up. So the more hash rate that gets deployed on the network, the less valuable your shares are going to be. Also, there is the block subsidy. So every 4 years, the block subsidy gets slashed in half. So you need to take that into account. Your mining rewards are going to go down. You can bake all this stuff into a formula, but I don't think the eHash protocol is necessarily the right tool. You can buy and sell eHash like in a granular level, but you're probably going to want to build some like higher level, do some maths and figure this stuff out.
That's the question: is how do you make eHash the product that gets traded for long-term miner hedging?
You could bundle it up. So eHash is so eCash tokens can be split and joined. So you can just join a bunch of eHash tokens into a very large token. You can bundle those tokens perhaps across mining epochs. I'm not sure. That's cool. I like that you're going there. I haven't thought about that before.
Because if it stays small, then the speculating feels like it might not find a product market fit. But if it allowed a miner to kind of sell forward hash rate for a quarter or a year, that's really valuable. And I'd love to see that develop as a protocol instead of like a Wall Street product.
Agreed. Protocols will take over the earth. You should build it.
Maybe I'll vibe code it.
Yes, absolutely. Vibe code it. Anybody else? Thank you.